You ever have one of those days where your tech just acts up? I mean, your GPS is suddenly off by a block, your Wi Fi router just decides to reboot itself, and you can't for the life of you figure out why. Well, what if I told you the culprit wasn't a bug or a bad cable, but an invisible storm of energy that traveled 93 million miles from the sun just to mess with your gadgets? Yeah, that's what we're digging into today. All right, so we're kicking off something really special here. This is part one of a big 10-part series, and it's all based on a super detailed report from the pros over at RFI Detectives, who are part of Virtualization Options LLC. They've done a deep, deep dive on the threat of space weather, and we're going to unpack their findings chapter by chapter, starting right now with chapter one. So here's the game plan for today. First up, we're going to get a handle on what space weather even is. Then we'll talk about why the stakes are just so much higher than they used to be. After that, we'll meet the sun's triple threat, learn how we actually measure these cosmic storms, and finally, look at how it all fits into this giant solar cycle. Let's get into it. Okay, first things first, what in the world is space weather? It sounds like something out of a sci-fi movie, right? But trust me, it's a very real force that has a huge impact on our digital lives. You know that feeling, right? That moment of just total frustration when your tech fails for absolutely no reason you can see? The RFI Detectives report kicks off right here, with these exact glitches, because a lot of the time they aren't random at all. They're actually symptoms of something much, much bigger. So when we hear weather, we think of clouds, rain, wind, that kind of thing. Forget all that. Space weather is totally different. Think of it as the sun constantly breathing out this stream of energy, charged particles, and radiation that flows through the solar system and slams into whatever's in its path, including us and all the technology we rely on every single day. Now, the sun has been doing its thing for billions of years, so this isn't a new phenomenon. But our vulnerability to it? Oh yeah, that has gone through the roof. Let's look at why we've gone from seeing a few weird sparks to facing potential system-wide meltdowns. Just look at the difference here. Back in the 1800s, a huge solar storm hit, and it made telegraph lines shoot out sparks and send messages that no one was typing. It was weird, a curiosity. Fast forward to today, that same level of storm could knock out GPS navigation for millions, silently corrupt critical data on corporate servers, and literally fry massive transformers in our power grid. The sun hasn't changed, the world we've built around ourselves has. So what does this actually mean for you at home? Well, it means a phone's GPS suddenly going haywire, that Wi-Fi router that keeps rebooting, or that smart thermostat that just won't update. It might not be a bug. And even worse, it could be a particle from the sun silently flipping a bit on your home server and corrupting those irreplaceable family photos, and you might not even know it happened until it's too late. And if you're running a business or you're in IT, listen up, because the stakes get even higher. That bizarre batch of corrupted records in your database, that false alarm on the factory floor that shut everything down, it might not be bad code. It could literally be a single high-energy particle that traveled 93 million miles just to flip a 0 to a 1 in your server's memory, wrecking your data or sending network traffic to the wrong place. Okay, so we get it. It's a big deal. But what is the threat exactly? How does the sun actually do this? Well, the report breaks it down into 3 distinct weapons in its arsenal. Think of this as our intelligence briefing. Know your enemy. Yeah, it's not just one big blast. The sun has a few different ways of coming at us, and each one is different. They have different travel times, different targets, and they cause different kinds of chaos. Let's break them down. First up, we have solar flares. These are the speedsters of the bunch. A flare is just this massive blast of radiation, X-rays and stuff, that erupts and travels at the speed of light. That means it gets here in just 8 minutes flat. Its main job is to mess with our upper atmosphere, which can cause radio blackouts and make your GPS signals go all wobbly. Next are the heavyweights, coronal mass ejections, or CMEs. These aren't just light and radiation. A CME is a literal cloud of 1 billion tons of magnetized gas that gets shot out into space. It's slower, taking 1 to 3 days to get here, but when this massive cloud hits Earth's magnetic field, it can trigger huge geomagnetic storms that create powerful currents in our power lines, powerful enough to damage them. And last, we have the stealth assassins, solar energetic particles, or SEPs. These are the really sneaky ones. They're tiny particles accelerated to almost the speed of light. They're so high energy, they can punch right through the shielding on a satellite, or even reach down to the ground.
And this is what causes that bit flip we were talking about, where one tiny particle hits a microchip and changes a 1 to a 0, corrupting your data at the most fundamental level possible.
So, with these three very different threats heading our way, the big question is, can we see them coming? And the answer is yes, absolutely. We can measure them, and we can even forecast them, kind of like a cosmic weather report.
Now, it's really important to see this as a chain reaction. It's not one single thing. It all starts with an event on the sun. Then that energy travels across space and interacts with Earth's magnetic field. That interaction creates physical effects here, like those currents and power lines, and that is what ultimately impacts our devices. You have to understand the whole cascade. And to make all this easy to understand, the experts at NOAA, that's the National Oceanic and Atmospheric Administration, have created these official scales. Think of them like the Richter scale for earthquakes. There's the G scale for geomagnetic storms that hit the power grid, the S scale for solar radiation that hits satellites, and the R scale for radio blackouts. They all run from a minor 1 to an extreme 5. Now, you don't need to stress about a G1 storm. But here's the practical takeaway from the report, the rule of thumb. Anytime you see a forecast for a level 3 or higher, a G3, an S3, or an R3, that's your cue. That's when you need to start paying close attention and maybe take some protective steps for your really critical systems. All right, finally, let's talk timing, because these storms aren't totally random. There's a rhythm to it all, a long-term pattern. And if we understand that pattern, we can actually plan ahead. You see, the sun has this sort of heartbeat, and it beats roughly every 11 years. It goes from a quiet period, called solar minimum, to a really active and stormy period called solar maximum. And the bottom line is simple. During those peak years of solar maximum, your chances of getting hit by an event that messes with your tech are just way, way higher. But, and this is a really big but, you can't just relax when things are quiet. The report makes this crystal clear. The biggest, baddest, most extreme events, like the legendary Carrington event back in 1859, they can happen at any time. So while planning for the cycle is smart, you have to stay vigilant all the time. And this all leads to probably the most important piece of advice in this first chapter, aimed squarely at business leaders. It's this: don't wait for the storm. The smart play is to budget for resilience and put your protections in place on the way up to solar maximum. That way, when the peak finally hits, you're not scrambling. You're already prepared. Okay, let's do a quick recap of part 1. Number 1, space weather is invisible, but it is a very real threat to our tech. Number 2, our complete and total dependence on digital stuff makes us more vulnerable today than ever before in human history. 3, the danger comes at us in 3 main ways: fast flares, powerful CMEs, and sneaky data-killing SCPs. And finally, the good news: we can measure it, we can forecast it, and we can use the solar cycle to help us plan for it. So now we know what space weather is. We know the threat, but that leaves one massive nagging question. How? How does this energy actually travel across 93 million miles of empty space to get here and cause all this trouble? That incredible journey is exactly what we're going to explore in part 2. See you then.